You previously learned that the dot product of two vectors is an indication of how similar or how different their directions are, and it's easily calculated by summing up the products of corresponding components. You also saw that the dot product can be calculated by performing an orthogonal projection of one vector onto the line occupied by the other. You can then multiply the length of the projection by the length of the vector that it was projected onto. But if you want to compare the directions of multiple vectors, which may all have different lengths, the dot product is not so useful. In this video, you'll learn how to calculate the angle between two vectors. First, we need to review some high school trigonometry. This is a right-angle triangle. We'll refer to this angle as theta. The longest side of the triangle is called the hypotenuse. The side of the triangle, which also forms part of the angle theta, is called the adjacent side. And this side, which is opposite the angle theta, is called the opposite side. Trigonometry tells us that the sine of angle theta is equal to the length of the opposite side divided by the length of the hypotenuse. The cosine of angle theta is equal to the length of the adjacent side divided by the length of the hypotenuse. And the tangent of theta is equal to the length of the opposite side divided by the length of the adjacent side. These formulas are incredibly useful. If we know the angle theta and the length of one side, we can calculate the lengths of the other two sides. Or, if we know the length of two sides, we can calculate the angle theta, or the length of the other side. For example, suppose you're standing 50 meters away from a tall tree, and you use a sextant or just a protractor and a piece of string to measure the angle between the ground and the top of the tree. You can calculate the height of the tree without having to climb up it, like this. Let's zoom in and take a closer look at these vectors and see how trigonometry can be applied to calculate the angle between them using only the information you can see here. First, label the angle you want to find as theta. Notice that the short vector and its orthogonal projection form two sides of a right-angle triangle. We already know that the length of vector v multiplied by the length of the projection is equal to the dot product of the two vectors. This can be rearranged to give an expression for the length of the adjacent side. Now, given that the cosine of theta is equal to the length of the adjacent side divided by the length of the hypotenuse, then the cosine of theta is equal to the length of the adjacent side divided by the length of vector u. When these two expressions are put together, we arrive at a formula that can be used to calculate the angle between two vectors. Let's give it a try. First, calculate the dot product of the two vectors, in this case 5.75. Next, calculate the length of v. That's easy enough, it's just the y component of v, 5. Then calculate the length of u. You saw how to do this in a previous video using Pythagoras' theorem. The length of u is 3. Applying the formula we've just derived, the cosine of theta is 5.75 divided by 15, which is approximately 0.383. So theta is the inverse cosine, the so-called arc cosine of 0.383. which, if you check on a calculator, you will find is the angle 67.5 degrees. That looks about right. This method will allow you to calculate the angle between any pair of vectors, regardless of their magnitudes and directions. So now you have a way to compare the directions of as many vectors as you like.